Okay, so we're going to start with some C sharp. We're going to go back to basics, and Visual Studio, local folder. You know, again, we're going to be in the web, but what we did was desktop apps, right? You remember that? And so I'll just create a file. Let's close this. I'm just going to create a desktop app. Close folder. So we're going to say create new project, and that's kind of where you start. Going back to basics, remember we've got console apps, we've got basically desktop apps. Windows Form apps versus Windows Form apps .NET framework. This is kind of the older code base. This is the .NET framework, which is a slightly newer code base. Kind of the same difference, console app versus console app. Really, we're not going to see any difference. So these are all templates that we can select over here. You get these templates through the installer. Depending on what you check during the installer, you get different templates. For the most part, in our second semester, we focused on the .NET framework, console apps, and Windows apps. And so here, you know, again, I'm just going to, this is just not that important as far as where is this going to go. I'm just going to delete it, right? So this is just demo code.
Is it the ASP.NET Core Web App Model View Controller template?
That's what we will be using, okay. Right? I'm going to just go back to not doing MVC stuff right now. I'm just going to be doing some, like what we did in second semester. A little review of that.
Would you be able to stream this on?
Yeah, let me stream it on Discord. So you can. Okay, and again, back to basics. Remember that a solution can hold multiple projects. And so what we did a lot of was like the solution would be for the chapter, like chapter 2. And then each project would be like lab 1, lab 2, lab 3, lab 4. And so, you know, it's pretty common convention that your solution is the big container, and your projects could be smaller containers. You know, a lot of times projects can work together to build the bigger application. And so you could have multiple projects come together to build a bigger app. And so this is just refresh C# code. This will make a folder for me for my solution, and we'll just call this demo 1. Create. Okay. And so remember, we got the old GUI, drag and drop, what they call rapid application development. And so the first thing in object-oriented programming is creating this thing called a class. Remember, a class is known as a blueprint of an object. And so just right out of the gate, we can kind of start with creating our class. And an object is just a term in object-oriented programming that's like, what I call it is a computer representation of a real life thing, right? So I learned that an object is like, you take your noun is a person, place, thing. I think it's also an event. Does that sound right? Going back to my English class. And so any noun can be a class. And this is your blueprint of any real world thing. So what do we want to create? We want to create a character, sure. Character. So this is our character class, and you can create generic characters this way. So what we're looking at here when we create a class is it has this keyword internal, which is our access modifier. Okay, we got public, private, internal, protected. These are your access modifiers, and they ultimately can control what parts of the code can work with this class. Public is the most wide open. Private is on the opposite end of the spectrum. Internal is kind of like internal to the project, and then protected is within that file itself and its children. So when you start talking about inheritance, and the children can see the protected variables. And so it kind of goes like this in terms of security, if you will. Public is the most wide open, then internal, then protected, and the most secure, if you will, is considered private. And again, these are just called access modifiers. They control what parts of the code can see other parts. So our class is by default marked internal. Quite often we would just go ahead and mark them public because that's kind of the point of the class, is to be worked with by other classes. And then you get started coding your class. Now, there's really two things about when you break down a class. A class has data and a class has methods. And the way that we work with data, I like to kind of go back to the Java days because it's like an evolution in like how you would code this. So I'm going to go back to like the early days of Java, which you could still code this way in C#. Which I might still have this. I'd be curious if you guys get as much IntelliSense as I get, or if I still got that Copilot running. It'd be interesting to see if you guys have the same kind of code suggestions that I have, or as we get into this, it's doing different. Well, kind of to start with the data, we started with this concept of an instance field. And an instance field is ultimately the data that you're working with. And so with an instance field, it will look something like private string character name. And remember, we did the underscore notation. Underscore notation identified that variable as an instance field. And so you could say name, you could say character name. Underscore name is fine. Okay, this is the character's name, and maybe we'll just do age, private int age. And Vinny jokingly said, what's a data type? And obviously we worked with data types, and we learned the differences between data types. We learned that a double takes up more RAM than an int, and or a double takes up more RAM than a float, right? A long takes up more room than an int. In the early days of coding, you really had to use the most restrictive data types possible because devices were not powerful like they are today. And so C# kind of hitting the basics here. C# is considered a strictly typed language, which means we have data types. Developers generally tend to like that because when you have a strict type, you generally know what's in your variable. Versus in JavaScript, you just have let this, and what's in this variable can change. It could be an int, it could be a string, it could be an object, it can be an array, it can be whatever you want, and that whatever you want can change. And so this just basically provides a little bit more structure about what you can put into your variables. And so these instance fields are at a basic idea underscore age. And then now that we have these fields for storing data, we need a way to do two things. We need a way to put data in, and we need a way to pull data out. And so when it comes to methods, there's a couple of things. I want to cover constructors. I want to cover mutators. I want to cover accessors. I want to cover ToString. Okay, and so these are all methods that are going to work with the data, right? And hopefully you guys are starting to remember some of this. We'll start with a constructor. A constructor is a method that runs when you build the object. So a constructor is a method that runs when I say when you build the object, I mean that's what construction is, right? But what does it mean to build the object? When the object is initialized, if I spelled that right, when it's put into RAM, right? So the data is not stored in RAM, and all of a sudden there's space for this object in your RAM. So that constructor is a method that runs when that space is made, when it's reserved in RAM. And a constructor has the same name as the class. It does not have a return data type. So we'll say public character. Okay? And this is a constructor. This constructor you get for free. You don't have to code this necessarily. This is called the default constructor. Okay, the default constructor, I say you get for free because, well, if I go back into my app and I do a form load, and now I do character, my character equals new character. Okay, this piece right here is calling that default constructor. Notice even though I don't have that default constructor coded, I can do this. Okay? Now, what is this doing? This would initialize my instance fields to their default values of basically null and 0. Right? So all your instance fields will get nulled out, they'll get zeroed out. 0.0 for floats, false for Boolean, and like empty, like there's like a char default that's basically an empty char or a null char, I guess you would say. So depending on the data type, like this name variable underscore name for my character would be null. And I think if I just throw a label on here that's called label 1, I go back into here on the form load. If I say label1.text equals my character, I don't have an accessor yet. I can't access that variable. So I need to write an accessor to read the data, right? So I'll come back to the constructor because I'm just using the default constructor. But let's write an accessor. An accessor is a method. Public is our access modifier. String is our return data type. And you call your accessors, they typically say get name. Remember this? You say get name, and then we're going to return underscore name. Okay, so this is a method that will read the instance field. Okay, now by default, that instance field is null. And I'm just trying to get this to say get name. It's a method. Okay, so our form should have a label in it that says null, just demonstrating. Well, I guess null shows up empty anyways. If we actually put something into it, of course, get name would return what we put into it. But null in a string, instead of saying the word null, it just comes up like nothing. Yep.
So just a reminder, can you initialize an instance field like with data? So like if you just wanted to, private string underscore name equals Evan, could you do that?
Yeah.
Is that bad practice?
No, and actually the book did a little bit of that yesterday, and so I'm wondering if you were just kind of remember that.
That's like
kind of like the default for all characters, if you will.
Yeah, I was gonna say, isn't that like the equivalent of like hard coding in something basically? Because it's like in the class. It's not. Like,
yeah, it's. If you want all characters to be named Evan by default, you could do that.
Okay.
But you probably don't want all characters to be named Evan.
Right.
But that's what that does.
Okay.
Yep.
Your label should return that, right?
It did. Yep. Okay. So if you want to set some like defaults, your character age is 123. And then let's write an accessor public int get age return underscore age. I really think this is my. It doesn't look like IntelliSense to me.
I mean, I'm coding along and it's doing the same thing.
It's doing the same thing?
Yeah.
I never know.
I'm getting the same
The boundaries between Copilot and IntelliSense are blurring. That's right. Yeah, I believe what they did is they took Copilot and put it into ChatGPT.
It was built on top of OpenAI, I guess, is the parent company, and I think that they built something like that.
Yeah. So now my characters have a default name and age, and if I go back to my label and I say get the name plus an empty string plus my character dot get age, voila. And now age should return an int, but it's concatenating it into a string. So it's taking that int and it should convert that into the string, and you get Evan123. Okay, so kind of hopping around a little bit. I'm going to take out kind of like the defaults here. And let's now go to mutators. And so again, if you do wind up getting your first job, and in that job you're writing like 1990s style Java, like you see these accessors and mutators. That's Java. And C# kind of started with that, and it evolved. Java hasn't done a good job evolving. Java has not had an update in a long time. C# does have updates.
Was there a big one recently?
Yeah, all the time. You know, it's Microsoft. They're still. Java's story is they got bought by, this company, then they got bought by that company, and I think they want to say Oracle owns them now, and they just haven't really kept up. But a lot of big software that's out in corporate America was built on Java, and so there's still Java. There's lots of Java jobs out there. But C#, if you remember, kind of comes from C++ and Java have a kid, and out comes C#. And then it just has been updated. Okay, so these mutators are also methods that look something like this. They have a void return data type. Remember, this is the data type that you're returning. And they come with a convention of set name. They take one input parameter called, in this case, we'll call it name. And this, now, okay, underscore name equals name is valid. This dot name equals name is the same thing. This dot syntax, this dot is considered a little bit more readable, because just like the underscore represents an instance field in our brain, the keyword this in C# means instance field. So this dot, if there was no indicator in the variable name, this dot name, you see this a lot where your instance fields don't have an underscore. So you've got name instance field and you've got name parameter. So your variable, your parameter and your instance field have the same identifier. So this dot name equals name says that the instance field equals the parameter. Okay, so you might see this again, just going back to how I've seen it in Java. But again, I do like the convention of underscore name, and then you do this underscore name. Okay. Yes.
Could you do that in the accessors too, like this dot name?
Yeah, you could return this dot name. Yep. And again, using the keyword this simply means this object's instance field. This object's instance field. Because there could be 100 objects. This object's instance field. It points it to the name of that particular object's instance field. Okay, so just how we have a mutator for set name, let's make one for set age, public void set age, int age, this dot age equals age. Okay, so now that we have set name and set age, notice there's 0 references, so we can go back to form load here, and we could say my character dot set name is Bob. My character dot set age is 1. Okay, run it out, and we get Bob is the age of 1. Of course, the benefit of creating a class is that we can create multiple character. By the way, bad class name. I mean, it's character, the char data type, character data type. Okay, critiquing myself. Your character equals new character, and then we could say your character dot set name is Bill. Your character dot set age is 3. Okay, strings are in quotes, ints are not, and then we can take my label dot text. And then we can append plus equals your character get name, your character dot get age. And because we probably want a line break in there, just do something like a \n, right, to put a line break in our label. And we've got 2 objects. Okay, that's great. But as we have more than 2 characters, you would probably evolve this into a list of characters, right? And how many times did we work with lists, right? A lot. And that's what we're going to do. We're going to read data out of a database and store it in a list. And so a list of characters would look something like this. List of character called my tunes equals new list of character. Okay, and then instead of having these different identifiers, my character and your character, comment those out. And we do my tunes, and then we say dot, well, there it was, dot add new character. My tunes dot add 2 new characters. My tunes sub 0 dot set name, so the first character, if you will, was Bob. My tunes sub 1 set name Bill. And you might say, well, that seems pretty efficient too. I would agree. You would put it in a loop and populate it that way, but set age to 1, my tunes and then you could use a for loop, foreach, var. It is also, you joke about data types, but C# does have the var data type, which you could put anything in. Var character inside of my tunes. Okay, you can loop through your list and print it out. Now check this out, right? This lets me get back into this. I've called set name and set age. I have not called get name and get age. A ToString is what data about the character do you want to spit out all at once, right? These accessors are one field at a time. If you want to read one field at a time, the ToString is a method that you override. There is a default behavior for a ToString in all of your classes. It's just not a useful one, so you have to override it. And you might say, character name, and I forget my template literal. I forget my character. Hold on, let me think. I was just coming from JavaScript. I knew I was gonna forget it. Hold on, $. Coming from JavaScript. So let's syntax.
Like app in C# or something?
Nah, well, you're thinking of. So here it is. Yeah, that's for that. It's just okay. Oh, you got to put the $sign up in the front. Remember that? You put the $signs up in the front, and then you can just quickly access the curlies. Okay, so let's put the $sign in the front. Then you just access the curlies. Character name underscore name is age years old underscore age. So the point is that a ToString is reading multiple fields at a time. You get to decide what data and how it looks, whereas an accessor just is one field at a time, right? A mutator is one field at a time. A constructor is as many fields as you want. Constructors put data into the fields, just like the mutators. ToStrings read data out of the fields, just like the accessors. So now that I've got this ToString for my characters, I can loop through my tunes and say label 1.
Is there a reason why you're using var and not just the character data type?
Just to show that you can.
Oh, okay.
var can take in an int. It's like the JavaScript var. It can take in whatever data type. And so you will see that because you're like, I'm going to get some data out of the database. I don't know what it is. You could put it in a var. And actually that was the autofill on the code generator. Label 1 dot text plus equals is an append versus an overwrite. Character dot ToString. Now we have a ToString that will print out the name and the age of Bob and Bill. Okay, there you go. It works. It's not pretty, but there it is. This was the silliness behind Visual Studio. You gotta learn all the quirkiness and like change the properties, auto size to false. Remember that? And then you can kind of like drag and drop and constrain. It's not overflowing. Right now it says character 1 Bob. Bob is 1 year old. Character name Bill is 3 years old. It's doing what I'm telling it to do. Of course you can.
With like space after the first one, you can like add a space after old.
That's right. So let's clean it up just a little bit. I'm gonna delete the text so it doesn't have a default text. And in my ToString, I could put in a new line right here. Right, for every character, print out that, and that should. Now you got Bob is 1 year old, Bill is 3 years old. Coming back. Coming back.
It's weird because the past like months I've been coding in Java because I've been making a lot of like Minecraft mods, and it's like similar with the mutators and the accessors, but
Yeah.
like you said, this feels almost like it's like a mix of the two. Weird.
Yeah. Yeah, like Java probably doesn't have this, what they call string interpolation. Like, again, it just doesn't stay completely up to date with the latest programming trends. I don't know when they started making that a thing in languages like 5 or 7 years ago or something, you know. And the syntax, like we just saw, is just a little bit different in C#. Going back to that though, remember again, so I did string interpolation, fun word. And there's this other syntax where you don't put the $sign up front, and I'll demonstrate that. Okay, so you can do this with the $sign up front, but if we were to say return some quotes, to get this to work, you gotta do string.format quotes, character name, and you use what was called a placeholder. and then it was this dot underscore name. So like this is just going to print out the character name, but this was a placeholder for the first variable, right? So my ToString now just prints out a name, and if I close this one and relaunch it, character name Bob, character name Bill. All right, so this is just a different syntax before the, again, this was kind of like the old way of doing it, and this is kind of the new way of doing it, right? Certainly, I'm a fan of the new way. Okay, so again, yeah, you're right. This is like a little mix of Java and otherwise. Let's go to constructors. Remember, we get a default constructor for free. That's what we're doing right here. But what if we wanted to put the name in and the age in when we construct the object? Anytime you add a parameterized constructor, like something like a public character, like this, and then you go bang underscore age equals age. Okay, this is called a params constructor, parameterized. If that's a word, I already just made that up. Parameterized constructor. Okay, it's a constructor with params. You no longer get the default constructor for free. So if you add one, you also have to do, like this should break this. See how that breaks?
That becomes the default, right?
The default's always empty.
Oh.
Yeah, the default's always empty. It's just
You
this.
just can't use it
You just can't use it unless you do this. You got to go, oh, okay, now I've got a default.
Oh.
So now I've got a default. Now I can use the default, and now that works.
Isn't this how you create overloaded constructors?
That's what this is. These are overloaded constructors. What does overloaded mean? It means it's a method with the same name but a different parameter list.
Yeah.
So two methods with the same name but a different parameter list are overloaded methods. When that method happens to be a constructor, that's an overloaded constructor.
If I remember right, once you start typing it, like IntelliSense, it tips you off that there's overload, right?
Yes, and so now if I kind of come here and I say mytunes.add, I could say new character, and as soon as I type these parentheses, that's the IntelliSense you're talking about. You can see I now have two options of this method to call. I can call the default or I can call the parameterized ones. So now I can pass it a string, Jan, comma, and an age is 10.
But it has to be in that order too.
And it has to be in that order. So now we've got Bob is 1, Bill is 3, Jan is 10. Going back to defaults. There was something called optional parameters, and so let me demonstrate. Let's just add another field, name, age, and private. Sure, our characters have a level, and comma int level equals 1. By default, our characters start out at level 1, unless you override it when you construct an object. So if you're using this constructor, Jan will be level 1. These characters, because they're using their level would be 0, right? Because level doesn't have a default value here. It only gets a default value if you use this constructor.
So if you don't initialize int level and you just do int level like no equals 1, is that gonna break it or it's just gonna be
Okay, so if you do this, it would break.
Okay.
Why does that break? If I wait for it, yeah, there it goes. Because now you've got a constructor that requires 3 parameters, and you're only passing it 2. Okay, but this is called an optional an optional parameter, meaning you can override the value of 1, but if you don't override it, it'll use this constructor, it'll accept the name and the age, and then it'll just assign the level of 1. Let's, in our ToString, let's also print out a character name is that many years old and level. Okay, so my first 2 characters, we're using the mutators, their level should be 0. And Jan's character should be level 1. And let's see where it broke, because I got the level 0. Jan is 10 years old, which is correct, and level 0. So let me go back. Oh. What I need to do here, underscore level equals level. I forgot that part. You guys with me why that didn't work?
Yeah.
And now Jan has a level of 1. Okay, but let me kind of go back here and I'll say mytunes.add new character Pikachu. He's old, yeah? How old is Pikachu? 40? And he is level 30. So Jan's kind of accepting that default level, whereas Pikachu is level 30.
Basically, it can be overridden is what you're trying to show us.
Yeah.
By
The
value.
default value can be overridden. It's also worth noting that the defaults have to come at the end of the parameter list, right? I could not take level equals 1 and put it at the beginning of the parameter list. It just has to be at the end. That won't work.
What if the entire thing is optional?
Then they can all be optional, yeah. Yep. All right. Now, again, this is using mutators and constructors, and you can have optional parameters on your normal methods too. Your normal methods can have optional parameters. It's just not, constructors. But because this was so common, mutators and accessors were done so common, your classes oftentimes would have a lot of data. And so, I'm thinking of Amel's project and his class, your truck or whatever it was, there was a lot of fields.
Yeah.
There were a lot of fields. And so for each field, you had to generate a different method, 2 different methods. And so let's just make up an example where your class had 50 fields. Well, at minimum, that's like 100 methods. And it is very common to have a lot of data that you're storing. And so this whole method way of putting data in and pulling data out kind of got an upgrade with this thing called with what they call properties. Properties, you'll remember as I start coding them. Let me kind of condense this. Okay, so a property is another way of putting data into our fields and pulling data out of our fields. So if I were to make a property, I would say public, again, access modifier. It returns a string. The convention is capital name. You would have a get block that would get name and a set blocks that sets underscore name equal to value. The value is what comes in. It's like the mutator, if you will. So this is a get block. The get block is the read block of code. The set is the write block of code. Okay. Now this property does the job of the set name and the get name. And so over here, back over here, let me go into my ToString. Well, we're not even using get name. We can directly, as soon as we put data in, we could pull it out. Let me just demonstrate using the properties instead of the mutators. So if I were to say my tunes sub-0, instead of set name Bob, it would be this. It would be dot name equals Bob. Same thing's happening. I'm putting data into the field, but one's using the property and one is using the mutator method.
So can we comment out set name and get name them if we're following along and it'll still work?
Well, you just have to now say my tune sub1 dot name equals Bill. Yeah, you just have to, if you're not going to use them, you can comment them out. Right? So let's get a property for the age, because right now I just have a property for the so here's my property for the name. Public int age. This is my age property. Return age, set age equal to value. Now, remember I said this is a read and this is a write? Let's just say I don't have a read. Well, this is a write only property. Does that make sense? All you're doing is writing. There's no read block. There's write only properties and there's read only properties, right? If there's a read only property, it's only a get block. So there's read only properties and there's write only properties and there's read write properties. So properties have read write, read, or just write. But let me just do a read write property. Get return age, set underscore age equals value, right?
Isn't there a shorthand of that?
I'm getting there. That's where we're going. But I'll tell you what, it's 1:30. We're at a good spot to stop. Let me clean this up and we'll send you on break. So now I can do mytunes.0.age equals 1. .age equals 3. So Bob is 1, Bill is 3. And that's putting the data in, and then I'm still using the ToString to get the data out. Bob is still 1, Bill is still 3. They're both level 0 because, well, we never set the level. Jan is, by default, her level is 1. Pikachu's 40 and level 30. So these properties are the upgrade to accessors and mutators. And to Ryan's question, what does that shorthand look like? We'll do that after a little break, right? So you guys want to take a break? The next stage in this, once you understand what a property is, and ultimately it's all about these instance fields, putting data in and pulling data out, right? You can put data in using a property. You can put data in using a constructor. You can put data in using a mutator, right? Pulling data out. You can pull data out using a property. You can pull data out using an accessor. You can pull data out using a ToString. But it's all about putting data in, modifying that data, pulling data out. And so kind of the next step is, and I was looking because it was, well, what version of .NET are we on? and it looks like version C#, I should say. C# version 9 looks to be the latest. So whatever that's worth. So this is always changing is my point. C# goes through versions, and there's new features of every version. And so at one point, these were what you had to work with. And then they made this thing called an auto-implemented property, which is your shorthand. And so an auto-implemented, well, what does auto-implemented means? It means that it creates the instance field for you.
I like those.
Remember those? And so when you have an auto-implemented property, you no longer have to create the instance field. Okay, and that's the biggest mistake that, when you're learning this stuff is, it's very common to say, okay, well, I want to make another property, so I'll say private. Again, that's traditionally private. Your instance fields are secure. Private, what do our characters want to have?
Weakness.
String underscore weakness. Okay. And so an auto-implemented property looks like this, and I like my old prop tab. You'll probably remember me saying that. Prop tab. String tab weakness. Okay. Well, when you have an auto-implemented property, you no longer need the instance field. It creates that for you on the back end. Okay. So now we can, in our characters, we could say my tunes sub-0 weakness property equals, and it's a string, so kryptonite or whatever.
They're weak to water.
Thank you.
Yeah, Pokemon.
Oh yeah, true.
Okay, so my tune sub-0 weakness is water. My tune sub-1. Sure, we're just going to stick with it. JavaScript's a little bit more flexible, single quotes versus double quotes. So keep it to the doubles. That's something I forgot. Whatever that's worth, I forgot it. And we do have a third character and a fourth, it looks like, right? So 2 and 3. Ice and wind, right? And then in the ToString, now we no longer have the field, but what you can do is directly access it through the property. And has a weakness of tab to accept. Oh wow, it doesn't want me to do that. Let me see. It wants a okay. So since there's no field, you just access. This is calling the get block of weakness, which returns the instance field underscore weakness that it created for you. Yeah.
I thought that you could, even if you didn't make that first instance field, that you could still do underscore weakness. Am I wrong on that?
So.
Even if it's not there, implemented, it'll still accept underscore weakness. But I think I'm wrong. Yeah. Never mind.
Not that I remember, but so okay. Now our ToString spits out the weakness as well, and it's kind of concatenating with line breaks. Kind of get rid of that. There we go. And spit that out. Now our 4 characters should all have a weakness: fire, ice, Pikachu. I'm probably screwed something up here. What's up, Vinny?
So is there ever a time that you wouldn't want to use this, or because this is the new and improved method?
Yeah, good question. Yes, the answer is yes, and the answer is because if all you're doing is putting data in and pulling data out, there's no rules on the data, then you can use auto-implemented. But if you need rules on the data, like the age has to be within a range, then you would set, okay, so values the data that comes in. You can have conditions in here, like if a value is less than 0 or value greater than 100, underscore value equals 1, right? So, or excuse me, underscore age equals 1. So it's a really great question because the answer is yes. And the question was, when would you not use auto-implemented properties? And the answer is when there are conditions that you want to validate against on the data. You need an if-else block to make sure the data is good, that kind of stuff. Why is my weakness for Pikachu not there? So here's Pikachu. That is character sub 3. Character sub 3.
Weird because mine worked.
Oh, because I think you have to like make the space bigger.
Is that all it is?
I think it might be, yeah.
It might be. Yeah, that's all it was. Okay, so auto-implemented properties, and like, so let's just say there's no. Okay, so let me do this whole thing over just with auto-implemented properties and show you how all of this code, like you don't even need all these overloaded constructors, okay? So now that we have auto-implemented properties, we can do something unique here. Okay, so we got name. I'm going to keep my fields. I'm going to delete all this. I'll keep my ToString. I'm going to delete this. Prop, tab, string, tab, name, enter, prop, tab. I keep typing proper. Prop, tab, int, tab, age, enter, prop, tab, int, tab, level, enter, prop, tab, string, tab, weakness, okay, character name, age, level, and weakness. Now, if you want check this out. This is really cool. So we no longer have these overloaded constructors. What we have are called object initializers, though. Okay, so what we're using is the default constructor, but you put this little curlies after here, and you could say name equals Pikachu. Oh, here, I'm gonna see if I can get my boss's Don Poll. See if I can get his attention. Age equals 100. It's not working. Okay. We'll go back to our Pikachu. Here's the benefit. This is so flexible. I could set my character's name and age. I can set their name, age, and level. And their weakness. Right? So these, when you have auto-implemented properties, it pretty much lets you put data in using this object initializer. You don't need 100 overloaded constructors. You kind of get it for free. And so now we've got 2 characters, and what's Pikachu's weakness?
Water, right?
Brown.
Or ground, yeah. So what happens if you want to have like a default level for this situation? Would that not work?
That kind of goes back to right here.
Oh, okay.
Yep. So the default level would be 1. And so let's do that. Let's add a tune without a level. And Bulbasaur, age is 20, weakness is fire.
Water. No, wait. Fire.
Fire.
Yeah.
Fire, ground, ice, and anything.
Okay, so here's our 3 tunes, but notice only the, here I'll put the level is 10, 30. This Bulbasaur does not have a level, right? But there's his default. So you'll see this. You'll see this right here in the code that we'll write like next week, right? So these are called auto-implemented properties. They create the instance fields for you, and you can set defaults. And it just, look at this. This is how much cleaner is this than having 15 overloaded constructors with all these mutators and accessors. Way clean. It simplifies it a lot.
Did you have 2 different like ToString methods? Because I mean, ToString is something you're just basically like making.
Yeah, I never have. You could, and so I have seen ToString call different things like public string. You know, you might say display.
Yeah.
You know, and then you could just in the display you could return the name and the age.
Okay. Yeah. You could have like unlimited. Whatever.
Yeah. And so. You wouldn't give them the same method name identifier, but I've seen that.
Yeah. Are you getting build errors when you try to run this? Mine's not letting me.
No. Let me pause and take a look. All right. The next thing that you see a lot in C# is inheritance, and this is in fact some inheritance right here. This is to say that this class called form form1 inherits from form, and so the parent is this side, and the child is that side. Okay, and that's kind of the syntax for inheritance. Now, what does it mean to inherit? It means you automatically get the non-private members of the parent. And so let me demonstrate it. We've got a pretty generic parent called character, right? And we've got some pretty generic fields or properties of this character. Well, there can be different kinds of characters. When you're talking about inheritance, it goes generic classes at the top of the hierarchy and specific classes the lower you go in the hierarchy, right? So to say that character is a parent of a different class, well, character needs to be a more generic thing than its children. Okay, so let me get into it. I'll make another class here. So I'll right click on my solution, add class. Now a more specific kind of character could be a Pokemon, right? Or I was thinking like Marvel and DC characters. So I'll do Marvel character. Okay, and so this is a child class that inherits from character. So what that allows me to do is it's just saved a lot of time. I don't have to recode these properties of name, age, level, and weakness, because these are non-private members just like these methods are non-private members of character. So if I were to go into form, I could have a Marvel character called MC1 equals new Marvel character. And I could set MC1 dot, and look, I get all these properties that came from the parent class. And so you can kind of go in here and do like that. Now, that's one benefit, okay? But you also get this thing, okay, so since my tunes is a list of characters, you could do something like this. And this is where you get into this polymorphism. That's a fun word that you might remember, where you have a parent on the left-hand side of the equal sign and a child on the left. And so you will kind of get into what this is all about once I get into it. So I'll say the parent is character, C1 equals new Marvel character. So the parent's on the left, the child is on the right. And so what's happening is a Marvel character is being casted or converted up. It's an upcast into a character. Okay, now what is this? Okay, why is this beneficial? Where you can have a child cast up into a parent. Let me demonstrate, because you really, I don't do this too much, but what you do is you pass children into parents. And so let's see if I can demonstrate this. So let's just say that my character, let's just say there's a method called run. Public string run, and it returns a string that says ran 3 steps forward. Whatever, it's just took some steps, and it's a string. And I think I'm doing. Give me a second. I'm trying to think how I need to demonstrate what I want to demonstrate. Marvel character then. Mark it as virtual so that I can override it in a child. So this method can be overridden in a child. And if I say public override, there's run. And return okay, so a character runs 3 steps, and a Marvel character should run 10 steps. And if I append label1.text, it's when those autocompletes get you. Label1.text equals my tunes sub 0 dot run. It's a method. Okay, this is going to override my label, so it should just literally say a string ran 3 steps. Okay, and then so running 3 steps because it's a character, but then if I make a Marvel character and I were to say C1.run because C1 is a Marvel characters, we get that running 10 steps. So you kind of see the difference here. Okay, so if I say C1.run, well, C1, this upcast is allowed to happen because a Marvel character is a character. And now when I say C1.run, it's calling the run inside of Marvel character. Okay, all right, now I'm getting somewhere. Well, what do I need to really finish this off is I need another kind of character. And then I can kind of consolidate this into an effective demonstration because right now it's almost there. So let's make another child, not Marvel character, but we'll make DC character. Add a class, and this is a DC character. DC character. Okay, and that inherits from character. Public. Yeah, you can have, yeah, you can keep inheriting. Like, so you could say Marvel character, and then you could say, give me a category of Marvel characters.
Well, I was saying more like, can DC character inherit from Marvel character? In this case, instead of just character.
Yes,
Okay.
but that's not the case, right? A DC character is not a Marvel character.
Right.
So that's okay. Let's talk about that. Inheritance is a relationship, meaning a Marvel character is a character, right?
Mm-hmm.
So do you now see why DC character would not inherit from Marvel character?
Right. You wouldn't want that. Because
Yeah.
They're two different like genres.
They're two different genres. They're two different things.
Yeah.
So inheritance is based on what things are. And so DC character is also a character. What did I want to override? I wanted to override run. And let's just say this returns 100. Okay. So character C1, let's get in and say, okay, DC character. So now C1 is a DC character. Of course, that's going to say 100 steps. Okay. Here's the idea to kind of give you the idea of this. Here's what I'm trying to say. Polymorphism. Okay? This is considered a pillar of object-oriented programming. It's, 5 pillars of object-oriented programming, and this is one of the pillars. It means that an object will behave like the class that it references. So since this character is a DC character, its run is one behavior. If it was a Marvel character, you'd get a different behavior. Not driving the point home. Poly means many. Morphism means forms. And so I would say to play the guitar is a different action than playing. Playing the guitar is different action. Playing method The guitar is a different action than playing the same playing method. Soccer. Okay. The action, the method is to play. But what it means to play will behave differently depends on what you're playing. Okay? So run is kind of doing the same thing, but running a Marvel character is different than running a DC character. And so doing this kind of upcasting allows you to say, okay, right now C1.run does one thing, but the same code. Here's the thing. C1.run can behave differently depending on what C1 is.
So, like if you were to change that method name from run to just action, something really generic.
Yes, action. And the Marvel character flies and the DC character walks. And so they're very different outputs. The code C1.run is the same code. Like I would think, if I was a beginner programmer, I would think that, hey, this line right here is going to do the same thing every time. And it just kind of depends. What is it actually going to do? Yeah.
So I'm trying to understand this. So if, like, depending on the noun, the verb can change. Is that
Depending on the noun, depending on what C1 is, the verb can change.
the definition of the verb?
That's right.
Because it can have the same verb. It can just mean different things.
It can have the same verb, but what is C1? In this case, it's a DC character. Yeah, that's a good way to put it.
Each character's run has a different action. That's not
Yeah. And so what you wind up seeing let's see if I can do this here. So after my form load, so I have a method here that takes one parameter. That parameter is a character. And if that character is a Marvel character or a DC character, this line of code will behave differently. Right? So here, let's kind of back this up a little bit. I'm going to back this up a little bit. I don't really need my foreach right now. Okay, so I've got a list of characters. Well, I can put Marvel characters and DC characters into that as well. So right now I've got 3 characters. Let's go ahead and add a mytunes.add new Marvel character. Name is Iron Man. Age is, let's just say he's 40. Weakness is
The Loch Ness Monster of poverty.
Poverty?
what is his weakness? I don't know. Humble, being humble.
The Loch Ness Monster?
Broke. Okay, it doesn't matter. Okay, I'm just being silly about it. I think he got beat up by the Hulk once, right?
Yeah.
Okay, we'll just go with that. And because we're just filling this out, we'll say he's also level 2. Okay. So in your lists called My Tunes, the 4th character is a Marvel character. And let me call do something and pass it My Tunes sub 3, right? That's going to call the run from the Marvel character class. The Marvel character runs 10 steps. So there's a couple things going on here. Number one, we got some upcasting going on. We've got a Marvel character being stored as a character, right? So that's upcasting. But when you tell that character to run, it calls the run method from the Marvel character class. Yep.
So if you go into the Marvel character class and you take out that it inherits character, would that not be able to sit in the list anymore?
It has to, yeah. In order to upcast, you have to inherit from. Yep. In order to upcast, you have to inherit from that parent. And in order to send a Marvel character into a character object, that's upcasting, right? So the reason this works, My Tune sub 3, is because a Marvel character is a character. Now let's just add, My Tunes dot add new DC character, Superman. He's probably pretty old at this point, right? Level is sure 300. Kryptonite, right? Kryptonite, maybe. Where did I screw up? Oh, I did level twice. Okay, so now DC character. And because DC character is a character, you can also upcast My Tune sub 4 and get the DC character runs 100 steps. So, my favorite example when I learned polymorphism was this one right here. Playing the guitar is a different action than playing soccer, right? And I think Josh put it together. It's like the verb is dependent on the noun. Like, what is C? In one case, C is a Marvel character, and in another case, C is a DC character. And depending on that noun, is it a Marvel or DC character, the behavior is different. And that is polymorphism. And that is a hard thing for me to explain, even though I've explained it for 15 years in a row, right? It's not, I guess that makes it not that easy. But I can demonstrate. I can do it. It just takes a lot of words. So we've done inheritance, we've done polymorphism, we've done classes, we've done objects, we've done instance fields, setters, getters, properties. That's a 2-hour wrap up of our C# class. Let me get my C# book and see what I'm forgetting.
What about interfaces?
Interfaces, thank you. Interfaces.
I don't remember that well.
I never really got that.
Yeah, interfaces. Good. Oh, and abstract classes. Those are a couple of things. That's all part of that one chapter. I think, you got a lot thrown at you in that chapter. If I'm not mistaken, it was just one. Okay, so we should start with an abstract class. Character is not an abstract class. It's just a normal class. To make something abstract, Well, you add the word abstract. Public abstract. Okay. Now characters, now it's obviously an abstract class. What does that mean? That means you cannot actually create it. You cannot just create a character. You can create a Marvel character, you can create a DC character, because those are regular classes. But the idea is that this thing is so generic that you would not create it in your software. So if we kind of go back here, we're going to get compiler errors because look, I can no longer create characters. Okay, so abstract classes are there purely to be inherited from. Right?
Like it's kind of like if you were like creating a Pokemon game, you would have a class called Pokemon because they all share like the same attributes, but you wouldn't just create I guess it's a bad example. Like
I know where you're going with it.
yeah.
Yeah.
It's a framework of a Pokemon.
Yeah.
You might create a character class. Pokemon might be a character, so you might inherit Pokemon from character.
Okay.
But you would never create just a character. You would create a Pokemon.
And then you might have like water Pokemon like
Yeah.
under that, and then you might have like the actual, subcategories.
Yeah, I always like doing, because again, it's like animal, dog,
Yep.
Chihuahua, Chai,
It's like
Wawa.
It's like the genus, species, family, all that stuff. Yeah. Like that's.
And then do they have? I'm sure there's different breeds. I don't know. Sure. How about like full bred or not? So under here you could say full breed, or So this could be, you could have a full bred Chihuahua,
Or a devil.
or
Mixed.
mixed. Right? So yeah, you just inherit down the chain.
It's like a file system.
And not, well, of course, under dog you could also have Rottweiler.
So then you wouldn't inherit Chihuahua with animal, you'd inherit it with dog.
Correct. So dog would inherit from animal, Rottweiler and Chihuahua would inherit from dog. And the idea is you get more specific as you go down the hierarchy.
Mm-hmm.
Another important thing, like as people, we have multiple parents, and in some language you can inherit from multiple parents. Not here. Single parent inheritance. Right? You cannot inherit from both. You cannot inherit from both animal and character. You're only inheriting from one. Okay? Except there's no exception. There's a single inheritance, but you can implement multiple interfaces, which is where we're going. We're going to talk about interfaces and what those are. Okay? Okay, so I left off on this idea of an abstract class cannot be instantiated, right? This is called instantiation when we're creating an object. And so I never actually instantiate a character anymore. It's either a Marvel character or a DC character. Of course, if you want to have another one, you could have Pokemon, so on and so forth. So that's the idea there. I also talked about that, like, you cannot inherit from character, comma, and another parent. But you can what's called implement an interface. And so I think of an interface like this. I think of an interface as a list of actions, so a list of methods that you're forced to implement. So that's the language they use. Interfaces are implemented. Parents are inherited, inheritance is child, parent. Interfaces, they call that, you implement the interface. And so it's a list of behaviors that you have to enforce. And so it does relate to me. I can think of video games because I understand them, because I played them. And one video game that I played, maybe you guys will relate to this, is League of Legends. And in League of Legends, it's been a long time, but there were a bunch of characters, and every character had a Q ability, a W ability, an E ability, and an R ability. If I'm not mistaken, those were the defaults. And I think the Q was the ultimate, whatever.
R was.
R was the ultimate?
Yeah, Q, W, E were just standard abilities.
Standard moves, right on. And so every character had to have a behavior. And so what you could do is you could make an interface for those behaviors. And then every character that you would create would have to have those abilities. It's forced behaviors. Let me see if I can demonstrate it for you guys in a way that makes sense. Oops, what'd I click? Close that. Right click, add, and you actually don't see interface on the quick, so you're going to say new item. I'm going to click interface, and I'll just call this abilities. And here, instead of it being a class, it's just the keyword interface instead of class. And what you're going to do here is list methods that without their implementation. Okay? And so these are really short, and so you say public string Q ability, and this is a method, and I don't even think you need, let's see what I'm forgetting here. Okay, so it doesn't even want an access modifier. There you go. So, okay, so we got a Q ability, we've got a W, E, R ability. Okay, so like a bunch of empty methods is all we're doing. Well, now we have this interface that if I go ahead and I add a new class, this will be a league character. Don't do it. League character is still a character, but it implements comma abilities. And syntax here. Okay, now we're on our way. Now I screwed up because the convention on interfaces is there to be the letter I. So I'm actually going to rename this to be I that represents an interface. And I'll call it I ability singular. So my naming kind of was no good. So I'm gonna call it I ability. There are multiple, so I'll just keep it plural. Enter. So the interface is called I abilities. My league character. So you would say it like this. The league character inherits from character and implements I abilities. Now this says, wait a minute, your league character does not implement Q ability, W, E, and R. So there's a nice little implement the interface. Now, okay. So now there's an E ability. Now this would be for a generic league character. Probably, like this would be we're still not specific enough.
Yeah, once you get the specific
Once you-
characters,
Yeah, I'm wondering, I might even just rename this to like Hecarim, right? Hecarim, who is my lead character. So my class called Hecarim is a character and implements I abilities. Now this is making more sense. My E ability returns a string. So it's forcing my character to have certain abilities. That's the idea behind an interface. It forces a behavior onto a class. Does that make sense?
Yes.
Right on. I got one yes. That means everyone's yes. Vinny, you spoke for everybody.
Like, can you pass in like an event handler, like the ability, like if they click, if they press E.
You got to wire that up, but absolutely. So like, you got to wire that up, but yeah. And so when they click a button, because we're not playing a video game, but yeah, it would be like a button click event in this case. And so e-ability, I will just return like, I know I keep doing that. AOE far damage, whatever. And then ultimately back over here, this is my output box called label 1. Here's my what did I say? What did I say in Q? Did I wire up Q?
Yeah, you did.
And now you just got to wire it up so that when you're on the form and they press Q, it clicks, you know, it actually clicks that button, so to speak, but error list says index was out of range. Oh, I got let's see what I got going on here. I don't have 4 tunes anymore, so let's comment that out. Not even okay. Now we're not crashing. It does not like Q ability. I don't think I wired up Q ability, did I? I did E ability. E ability, not.
I'm sorry. I thought it was cute.
It's all good. Let's go back to Hecarim. Let's wire up my E ability on my form. Property E. Okay. I like this example because it's like, hey, and if I go back to Hecarim, what was happening? It was throwing an exception. The exception was not implemented exception. Remember, an exception is just the program crashing. And what I did here is I said, you know, to implement the interface, and it just coded all these for me. So the idea is that you need to actually do something in each one of these, right? But if you don't do something in it, it's going to crash. You guys want to go over try catch?
Yeah.
Do a little try catch. And exception handling will be next. So we covered abstract classes, we covered interfaces. Now interfaces are things that you can create. There's also a bunch of like built-in interfaces. And so one of the things that we did in the class is we made a class that was enumerable, meaning you could loop over it. What does it mean to loop over a Hecarim? You know, you kind of have to define that. And, you know, point is, you can make your own interfaces, or oftentimes you implement interfaces that are pre-built. So I'm sure that's something that we will do. Okay. My code crashed because I had this W ability right here, and my W ability for my Hecarim, my W was not implemented. So if I kind of go back here, and I click, this needs to say W, but it says the method or operation is not implemented. So let's go back. Let's kind of talk about like your program crashing. First off, the first thing I would say about this, depending on the software, this is so interesting to me. It might be okay to crash. Certain software is just way more important than other software. If your software is controlling rockets, like for SpaceX, you probably don't want your software to crash. If your software is monitoring patients' lives at the hospital, you probably don't want it to crash. You know, if your software is, I don't know, if your software is looking at Instagram, I don't know, it might be okay that you're scrolling, your Instagram feed crashes.
The Rankin food ordering system.
That's a great example. If you're just the food ordering system, what happens? You reboot the thing, you put the data back in, you order the food. It's not critical. So,
I know, sometimes during that dinner rush, a crash is the worst thing I can happen.
well, what does it mean? You just gotta wait a little bit. You know, my point is that sometimes there's lives on the line, or there's millions or billions of dollars on the line. And I had a graduate go work for the United States Post Office, and he was like, yeah, we didn't try catch anything. He was like, if it would crash, it would crash. We'd reboot. We'd put the data back in. Like, no try catches. And so that was kind of interesting to me. But the whole point of a try catch is to stop. The point of a try catch is to stop runtime crashes from occurring. Okay? The idea is like, hey, this behavior is causing our software to crash for one reason or another, and you want to stop that and maybe give the user an error message, right? And stop it from crashing. Try catches are expensive in the sense that they will slow your, if you do a lot of them and you're doing them with big try catch blocks, they tend to be processor intensive, and so it comes at a cost. When I was first learning try catch, you know, it was long enough ago that I would like witness my software running slower, like because I was on an old computer, and I literally would like watch a second or two go by when I knew my code hit a try block. And so that's why you might not put in try blocks, try catch, because they can be considered expensive. They are known as an object-oriented way for handling errors. You know, errors that crash your software. And so an alternative to try catches would just be loops and if statements. This is a traditional, meaning non-object oriented, way of handling errors. So in a lot of cases, not all cases, but in a lot of cases, you can get away with not using try catches if you just do some data validation with loops and things like this. But we saw that this little code crashed my program. Remember, I'm just going to change this letter to W because it bothers me. It's not my E, it's my W. Okay, and this one right now, and when you were learning to code, you would see this all the time, and you'd go, what is this, you know? And it's an exception. It is crashing your program. Exceptions, if they're not caught, if they're not handled, meaning caught or handled, whatever you say, means the same thing. If exceptions are not handled, it crashes your software. So, and that might be okay. And so what do? Well, you take the line of code, you wrap it in a try block, and you can catch, we know what kind of exception this is. I think it's a not implemented exception, E. Label1.text equals tell your programmer to finish his job, his or her job. And so it really wants me to use E. It's declared but never used. Since I'm not using it, I'll delete it. So now instead of crashing my program and giving the user like a crash message, we give them a more friendly error message. And it's still running. It hasn't crashed. And because my computer's so fast, you didn't see the expense. But could you not handle this with a if-else statement? In this case, I don't know that you could. If you're like validating user data, like, you know, making sure they don't leave fields blank, and that's one thing, but it's object oriented, right? This not implemented exception is what is thrown right here, right? So that's how I knew what to catch. Yeah, right.
What if you don't know what to catch?
It tells you. Check it out. If you don't know that this is a not implemented exception, well, there's a couple ways to answer that. But let's check this out. Let's just take my try catch out, and let me show you how to answer that question. So when you click on W, the details will tell you system not implemented exception.
So then I guess there'd never be a time where you would put a catch and you wouldn't know what to put in the catch.
If you can see the exception text, like I can get it right here, yeah, you absolutely would. Typically what happens is instead of, you might log this. And so there's system logs and application logs. And so instead of showing this, it'll just crash the program and then log it. But the idea is, yes, as a programmer, if you can get the message, the exception message, you know what to catch. The other way of answering that question, I'm coming to you, Vinny. The other way to answer that is because I know a little bit about inheritance. I know that all exceptions have a parent just called exception. So because not implemented exception, so I would say not implemented exception is a child of exception. So not implemented exception would be thrown. It would be upcast into exception, and exception can catch it. Label one. So now, why you don't do this for every exception is you might have different error messages, right? You just can't catch exception and have a blanket error message. There might be different things crashing your software. So if this exception is thrown, you probably want a specific error message. See what I'm saying? Answer your question? What's up, Vinny?
You can answer my question, but I was going to throw a curveball at you and say, like, what if you're making a rocket ship on a C# and you can't afford to like test it and have it crash to see what kind of exception you're dealing with?
Yeah.
You know what I'm saying?
Your rocket ship,
this kind of answers it, where you just call it a general, general exception.
Yeah, there you go. I mean, there is a well-known, I told you that in the C# class, if you guys remember, there's like a well-documented rocket that blew up because of an overflow problem. Remember that? overflows when you try and take a number. Like ints can only store numbers up to like, I want to say like 32 million. So if you try and store 34 million in an int, it doesn't have the capacity to do that. So it overflows the container, and that 34 million becomes like negative 2 million or something. Like it wraps around into the negatives. And this overflow problem blew up a rocket and cost the company a lot of money. Overflow rocket explosion. This was in 1996. The Arian 5, is that right?
This thing was built with C#.
No, it wasn't C#. It was probably C++ or something. Overflow. Okay, so here, the greater values caused a data conversion from a 64-bit floating point number to a 16-bit signed integer value to overflow and cause a hardware exception. The programmers had protected only 4 out of 7 critical variables against overflow. Blah, blah, blah. They were. They were.
Were there people on that?
Who hire these guys?
Were there any people on that flight? Or on that,
They were praying for time. Like, yeah, it's fine.
There's 7 of these, but we knock out 4. More than that, right?
It doesn't. I'm not reading about people.
yeah, it was probably like some sort of like satellite or something.
Yeah. It says the cluster consisted of 4 1,200 kilogram cylindrical spacecraft.
Okay.
Something or other. Probably satellites. Yeah.
I think they lost their job.
Oh yeah.
Funny, it says they just reused the code from Arian 4, and that's why people.
Noah and I were saying they were banking on adding DLC on the way up.
Oh yeah. They were waiting for a patch.
Yeah.
Okay, we're going to stop here. I think that covers a wide range